March 23, 1945, Rhine River, near Oppenheim. The river moved in darkness. Cold. Wide. Silent except for the current pressing against steel hulls and canvas pontoons. On the western bank, engineers worked without headlights. Only shielded lamps. Hands black with grease. Breath visible in the night air. Sections of treadway bridge were lowered into the water with dull metallic thuds. Chains tightened. Pins locked. Orders passed in low voices. Across the river, German artillery searched blindly. Occasional shells fell short, throwing columns of water into the black sky. The engineers did not scatter. They kept assembling. Behind them, tanks waited in long shadowed columns. Sherman crews sat inside idling machines, listening to the clank of steel being joined in the dark. They had been told to expect delays. Rivers were supposed to slow armies. But before dawn, the bridge would be ready. And when the first American armor rolled across the Rhine overnight, it would mark the collapse of a belief deeply rooted in German military engineering, that great rivers could buy time. To understand how that belief unraveled, we must step back to the war that made rivers strategic fortresses. In European warfare, rivers were never just geographic features. They were defensive systems. From the Napoleonic Wars to the First World War, commanders treated major rivers as natural fortifications. Wide water obstacles forced armies into predictable crossing points. Bridges became chokeholds. Destroying them bought time. Holding the far bank offered elevation, visibility, and prepared artillery positions. German military doctrine absorbed these lessons deeply. During World War I, the Rhine had served as a secure internal artery, an industrial spine feeding the Western Front. After defeat in 1918, German strategic thought increasingly focused on defense in depth. Rivers became calculated delay lines. Any invading force would have to halt, prepare bridging equipment, gather engineers, and expose itself to artillery while constructing crossings. Time. That was the currency. When World War II began in September 1939, Germany used rivers offensively during its early campaigns. In Poland and France, rapid bridging operations by Wehrmacht engineers allowed armored spearheads to maintain momentum. The lesson appeared simple: mobility wins. But by 1944, the strategic situation had reversed. After the Allied landings in Normandy on June 6, 1944, German forces were gradually pushed eastward. By August, Paris was liberated. By September, Allied armies were approaching the German frontier itself. Now the rivers of Western Europe, the Seine, the Meuse, the Moselle, the Ruhr, and ultimately the Rhine, became defensive anchors for a retreating Wehrmacht. Each withdrawal followed a pattern. German engineers prepared demolition charges on fixed bridges. As Allied units approached, bridges were destroyed in carefully timed explosions. Steel and stone collapsed into the water. Road networks severed instantly. Pursuing armor halted at shattered riverbanks. The aim was not permanent denial. It was delay. German commanders believed Allied river crossings required days, sometimes weeks, of preparation. Heavy bridging equipment had to be transported forward. Reconnaissance conducted. Artillery suppression arranged. Engineers assembled. Pontoon systems positioned carefully under fire. This was how rivers had functioned for generations. And in late 1944, Germany desperately needed delay. After the failure of the Ardennes offensive in December 1944, Hitler's last major gamble in the West, German reserves were exhausted. Fuel shortages crippled armored units. The Luftwaffe barely contested Allied air dominance. German military engineering doctrine had long treated major rivers as predictable delay lines. Bridges would be destroyed. Crossings would require heavy preparation. The attacker would pause. German field manuals assumed that constructing a stable crossing over a wide river under fire demanded coordination, aim, and vulnerability. Artillery batteries positioned on elevated eastern banks were meant to exploit that pause. Forward observers would adjust fire onto pontoon assembly sites. Luftwaffe aircraft, where available, would strike bridging points. Even in 1945, these assumptions persisted. When the Ludendorff Bridge at Remagen was captured intact on March 7, shock rippled through German command channels. The bridge had been wired for demolition. Charges were detonated, but structural damage proved insufficient. American infantry crossed immediately. Yet many German officers believed the situation was temporary. They assumed the bridge would collapse. And it did, 10 days later under accumulated stress and damage. What they did not fully anticipate was redundancy. Within days of the Remagen crossing, U.S. engineers had already completed multiple pontoon bridges nearby. When the original span fell into the Rhine on March 17, American forces did not retreat. They continued crossing. The calculation inside several German headquarters was increasingly unstable. River defense doctrine relied on singular choke points. American practice replaced choke points with networks. By late March, as preparations for large-scale crossings began north and south of Remagen, German engineers faced a sobering realization: they could destroy fixed bridges, but they could not destroy industrial capacity arriving by truck convoy. And that industrial capacity was now massed along the western bank. The fall of the Rhine barrier directly facilitated the encirclement of the Ruhr industrial region. Allied planners had long recognized the strategic importance of this area. Coal, steel, and synthetic fuel production were concentrated here. With river crossing secure, U.S. forces moved swiftly into the Ruhr, cutting off retreating German formations and accelerating the collapse of the Western Front. Supply lines ran uninterrupted across multiple crossings, enabling continuous pressure on withdrawing German units. The tempo of advance left little opportunity for the Wehrmacht to establish effective rearguard actions. Casualties among American engineers were significant but dwarfed by the strategic gains. 28 engineers were killed when the Ludendorff Bridge finally fell, and dozens more were wounded during construction under artillery fire along other crossings. Their work, however, exemplified the combination of technical skill, courage, and logistical precision that enabled entire armored divisions to roll across what had previously been considered a near impenetrable barrier. Reports from the U.S. Army highlighted the effectiveness of rapid bridging operations, noting that engineer-led initiatives had saved valuable days of advance that might otherwise have been lost to delays or German countermeasures. From a German perspective, the Rhine crossings were a shock. Intelligence reports underestimated the speed and scale of U.S. bridging capabilities. Commanders on the eastern bank had anticipated a pause, expecting the Allies to spend days organizing pontoons and treadways. The actual crossing occurred within hours. Soldiers, accustomed to methodical preparation, faced advancing armor and infantry before defensive artillery could be properly adjusted. The psychological impact was as significant as the physical. Defensive doctrine rooted in centuries of river warfare was rendered obsolete overnight. By the end of March 24, multiple American divisions were entrenched east of the Rhine. Engineers continued working, expanding bridges, repairing damage, and constructing additional spans to ensure uninterrupted traffic. The river had been crossed overnight. Armor had rolled across, artillery had been positioned, and the expected pause had been erased. For Germany, it was a strategic shock. For the Allies, it was a validation of preparation, innovation, and the integration of industrial capacity into battlefield tactics. The Rhine, symbol of centuries of defensive thought, had been neutralized, not by overwhelming force at a single point, but by speed, coordination, and engineering mastery. The consequences would ripple immediately across the Western Front, reshaping defensive planning, accelerating the collapse of German forces in the west, and opening the path toward the Ruhr and the heart of Germany itself. By the end of March 1945, the Rhine crossings had fundamentally altered the balance on the Western Front. What had been expected to serve as Germany's final natural barrier now offered little resistance to advancing Allied forces. The Ludendorff Bridge, though collapsed on March 17, had already fulfilled its strategic purpose, allowing tens of thousands of American troops to establish a foothold east of the river. The pontoon and treadway bridges constructed afterward ensured that armored divisions and artillery could move rapidly, consolidating gains and expanding bridgeheads without pause. German forces, under orders from high command, attempted to organize counterattacks, but they were too slow. Defensive positions that had been meticulously prepared along the eastern banks were quickly outflanked. Units intended to hold bridges and riverbanks were forced into rapid withdrawals toward the interior, abandoning both fortified towns and industrial installations. For centuries, rivers in Europe had marked boundaries, political, cultural, and military. The Rhine, in particular, carried symbolic weight in German history. It had been romanticized in literature and propaganda as a protective frontier. By March 1945, that symbolism still lingered among civilians and soldiers alike. When American armor began appearing east of the Rhine in multiple sectors almost simultaneously, the psychological effect was profound. German units expecting days of warning suddenly faced tanks within hours of initial contact reports. Defensive plans based on staged resistance lost coherence. Communication networks, already strained, struggled to adjust to rapid breakthroughs. The crossing at Remagen alone allowed thousands of American troops to establish a bridgehead before German high command could coordinate an effective counterattack. Subsequent crossings multiplied the effect. Reports from German field units described confusion. Units withdrawing toward presumed defensive lines discovered those lines already compromised. Engineer officers tasked with organizing demolition found themselves outpaced. The river had not bought time. It had been crossed overnight. This erosion of confidence mattered. Military defense relies not only on physical barriers but on belief in those barriers. When that belief collapses, resistance weakens in ways that statistics alone cannot measure. By the end of March 1945, Allied forces were streaming across the Rhine along a broad front. What had been expected to slow an invasion had instead accelerated its final phase. And in the darkness of March 23, 1945, under artillery flashes and the dull rhythm of steel locking into place, the decisive test of those assumptions was already unfolding. Meanwhile, American engineers raced against time. The Ludendorff Bridge had been built in 1918 for rail traffic. It was not designed to carry sustained armored traffic under combat stress. Engineers reinforced it with timber supports and steel bracing. Traffic was regulated carefully to reduce vibration. But reliance on a single crossing was dangerous. By March 10, engineer units began constructing pontoon bridges upstream and downstream from Remagen. Inflatable pontoons were launched into the Rhine under cover of smoke screens. Steel treadways were pinned together section by section. German artillery found the sites quickly. Shells landed among the floating sections. Pontoons were punctured. Repair crews worked continuously. Replacement sections were hauled forward by truck convoys arriving day and night. On March 11, the first pontoon bridge near Remagen was completed. Tanks began crossing almost immediately. By March 14, additional spans were operational. Traffic increased. Supply trucks, artillery pieces, and armored columns streamed eastward. The German High Command had anticipated that even if a bridgehead were established, expanding it would require time. Instead, the opposite occurred. The presence of multiple crossings created momentum. Reinforcements flowed across faster than German counterattacks could organize. Still, the Ludendorff Bridge itself remained vulnerable. On March 17, at approximately 3 p.m., after 10 days of sustained damage and stress, the bridge finally collapsed into the Rhine. 28 American engineers were killed in the fall. But by then, its strategic purpose had already been fulfilled. More than 25,000 American troops had crossed. Multiple pontoon bridges were fully operational. Armor and artillery were entrenched on the eastern bank. The fall of the bridge did not end the crossing. It merely shifted traffic entirely to the engineered spans nearby. So engineers were embedded directly into advancing formations. When German forces destroyed bridges over the Seine in August 1944, American engineers erected replacements quickly enough to keep armored columns moving. Similar rapid crossings occurred at the Meuse and Moselle rivers later that year. Each successful operation reinforced a pattern. Rivers did not halt American advances. They slowed them briefly, then disappeared beneath steel. German intelligence was aware of Allied bridging capabilities. Reports acknowledged the existence of portable systems and engineer battalions. But many German planners underestimated the scale at which the United States could deploy them. Industrial production in America had reached staggering levels by 1944. Thousands of bridge panels, pontoons, and transport vehicles were available. Entire engineer units trained specifically for night assembly under combat conditions. And perhaps most importantly, Allied air superiority meant that German artillery observers and aircraft had limited ability to disrupt large-scale bridging operations. By February 1945, as Allied forces pressed toward the Rhine, American commanders were not asking whether they could cross. They were deciding where, and how fast. Then, on March 7, 1945, an unexpected opportunity appeared at Remagen, the Ludendorff Bridge, still standing. Its survival would accelerate events dramatically. But even without it, U.S. engineers had already prepared to build their own crossings across the Rhine in multiple sectors. The assumption inside many German staff offices was that a deliberate Rhine crossing would require careful preparation and significant time. They believed they understood rivers. What they did not fully grasp was that by 1945, American bridging was no longer merely an engineering function. It was an extension of industrial warfare. Designed to erase natural barriers overnight. By early 1945, Allied forces stood along the western banks of the Rhine, the final major natural barrier before the German industrial heartland. The Rhine was not just symbolic. It was operationally decisive. Flowing roughly 760 miles from the Swiss Alps to the North Sea, the river cut across western Germany like a defensive moat. In many sectors it stretched 300 to 400 meters wide. The banks were often steep. The current strong. For German planners, the Rhine represented the last reliable obstacle capable of forcing Allied armies into pause. And pause meant survival. If the Allies could be delayed long enough, perhaps political fractures would emerge. Perhaps Soviet pressure in the east would shift priorities. Perhaps new defensive lines could solidify around the Ruhr, Germany's industrial core. So demolition teams prepared. Bridges were wired. Crossing points surveyed for artillery coverage. Defensive positions entrenched along high eastern banks. The expectation was clear: if the Allies reached the Rhine, they would have to stop. But across the river, American doctrine was evolving in a different direction, one that treated delay as unacceptable. And that difference would soon decide whether the Rhine remained a fortress or became a roadway. By early 1945, the United States Army did not view rivers the way European armies traditionally had. To American planners, a river was not primarily a defensive wall. It was a logistical problem. And logistical problems could be solved with steel, training, and scale. The U.S. Army Corps of Engineers had expanded dramatically after 1941. What had once been a relatively small peacetime branch became a vast wartime organization. Engineer combat battalions, armored engineer battalions, and specialized bridging units were formed, trained, and shipped overseas in large numbers. And the coming days would test that belief under artillery fire and searchlights on the Rhine itself. Combat engineers occupied a strange position in the American Army. They were builders in a war of destruction. Most were young, often in their early 20s. Many had civilian backgrounds in construction, carpentry, mechanics, or civil engineering. Their training included demolitions, mine clearing, and bridge construction under simulated combat conditions. But training yards in the United States did not include incoming artillery. On the Rhine in March 1945, engineer units such as the 291st Engineer Combat Battalion and others attached to 1st and 3rd Army faced direct fire while assembling bridges. German artillery batteries on the eastern bank targeted crossing sites as soon as they were detected. Bridging work required exposure. Men stood on floating pontoons, balancing heavy steel treadways. They worked with hammers and locking pins while currents pushed against their supports. If a section drifted out of alignment, it had to be wrestled back into place manually. Unlike infantry, engineers could not dig foxholes once construction began. The bridge itself was the mission. Stopping meant delay. Delay meant giving the enemy time. Casualties occurred. Shell fragments tore through pontoon sections. Engineers were wounded while guiding vehicles onto incomplete spans. Replacement crews stepped forward immediately. The work continued. Their objective was not heroism. It was completion. And in many sectors along the Rhine, completion came faster than anyone on the opposing bank expected. The Rhine crossings of March 1945 remain a defining moment in modern warfare. For centuries, rivers had represented more than water. They were barriers, symbols of territorial defense, and natural regulators of operational tempo. Commanders had long relied on them to shape battle plans, to buy time, and to impose order on advancing forces. The U.S. Army, however, approached the Rhine differently. To them, it was not an obstacle but a challenge. One to be measured, engineered, and overcome with precision. The courage of the engineers, working in darkness and under fire, embodied a new dimension of warfare, the human and the technical intertwined. Each bolt pinned, each pontoon launched, each treadway secured was not only a construction task but an act of strategy in motion. These men transformed the river from a barrier into a bridge for momentum. Their labor proved that discipline, planning, and skill could achieve what traditional doctrine considered impossible. Technology, production, and doctrine converged. Modular bridges, standardized components, and industrial logistics made it possible to move entire divisions across wide, fast-flowing rivers overnight. Speed became more than a tactical advantage, it became a psychological weapon, eroding the enemy's confidence even before combat engagements could unfold. German forces, trained to calculate delays and prepare defenses, found their assumptions overturned in hours, not days. The Rhine crossings also marked a turning point in the relationship between industry and battle. The ability to mass-produce, transport, and assemble bridging systems under fire demonstrated that the tempo of war was no longer dictated solely by terrain or enemy positions. Mobility, preparation, and engineering became decisive factors, shaping not only the course of World War II but the doctrines of post-war militaries worldwide. The bridging systems themselves were not miraculous inventions. They were practical tools. The Bailey Bridge, though British in origin, became an American industrial product by scale. Over 200,000 panels were produced in the United States during the war. Configurations could be adjusted depending on span length and weight requirements. Double or triple panel constructions increased load capacity for tanks such as the M4 Sherman, weighing roughly 30 tons. For wider rivers like the Rhine, floating treadway bridges became decisive. The M2 treadway system used steel trackways mounted on pneumatic pontoons. These pontoons could be inflated quickly and anchored against current. Sections were connected in sequence, forming a continuous roadway. What made these systems transformative was not their design alone, it was logistical abundance. American divisions often had multiple bridging sets available simultaneously. Engineer battalions traveled with their equipment close behind advancing combat units. Replacement components were stockpiled. In contrast, by 1945, German engineer units faced shortages of materials, fuel, and transport vehicles. Air superiority restricted daytime movement. Many demolition operations succeeded, but rebuilding under pressure became increasingly difficult. Technology amplified doctrine. American industrial output allowed commanders to treat bridges as consumable tools rather than singular strategic assets. If one crossing was destroyed, another could be built nearby. This multiplication of options strained German defensive planning. For centuries, rivers imposed natural limits. In March 1945, on the Rhine, those limits were becoming negotiable. And as engineers tightened the final locking pins under cover of darkness, another perspective, from the German side of the river, was beginning to confront an uncomfortable reality. American High Command understood the psychological and operational value of crossing the Rhine quickly. General Dwight D. Eisenhower, Supreme Allied Commander, approved a broad front strategy designed to overwhelm German defenses simultaneously. Rather than a single thrust, multiple armies would cross in coordinated operations. General Omar Bradley's 12th Army Group prepared to expand bridgeheads at Remagen. Meanwhile, General George S. Patton's Third Army sought its own crossing points farther south. To the north, Field Marshal Bernard Montgomery organized Operation Plunder, a meticulously planned assault crossing near Wesel scheduled for late March 1945. Patton, characteristically impatient, ordered a crossing near Oppenheim on the night of March 22 to 23, 1945, ahead of Montgomery's main effort. Engineer units moved into position quietly. Under cover of darkness, assault boats ferried infantry across first. Once bridgeheads were secured, pontoon sections followed. Treadway bridges were assembled rapidly in the current. By early morning on March 23, elements of the U.S. 5th Infantry Division had crossed. Soon after, armored units began moving over newly completed bridges. Patton later remarked in his diary that the Rhine had been crossed, without any great difficulty. The statement reflected not arrogance, but preparation. Commanders no longer viewed the Rhine as an obstacle to overcome eventually. They treated it as a timing problem to solve immediately. And solving it quickly denied German forces the chance to reorganize deeper defensive lines. The ability to mobilize, transport, and assemble bridging equipment under fire showcased the United States' capacity to merge engineering, logistics, and combat in a single, fluid system. For American forces, the experience reinforced several key principles. Redundancy is decisive. Multiple simultaneous crossings minimized risk and prevented a single failure from halting the advance. Speed multiplies effectiveness. Engineers and combat units synchronized their efforts to exploit the earliest possible window, often under darkness and artillery fire. Technology must be coupled with doctrine. Standardized, modular bridges, Bailey, M2, M3 Treadway, were only as effective as the units trained to deploy them under combat conditions. The U.S. had anticipated both design and human factors in their application. Psychology is as crucial as firepower. German troops expected rivers to delay the Allies. Overcoming these expectations disrupted enemy defensive planning and accelerated operational collapse. For German military planners, the Rhine crossings exposed limitations in doctrine that had not kept pace with the industrialized tempo of modern warfare. Reliance on static defenses, single points of delay, and delayed countermeasures proved inadequate against rapid, multi-point assault crossings. Post-war analyses by German officers repeatedly cited the speed and efficiency of American bridging as a central factor in the collapse of Rhine defenses. They recognized that engineering capacity could offset what were previously considered insurmountable natural barriers. The Rhine operation also influenced post-war military thought. NATO engineers studied the use of pontoon bridges and modular treadway systems to ensure rapid mobility in potential European conflicts. River crossings became exercises not only in construction but in combined arms coordination, with integration of infantry, armor, and artillery as standard practice. American operational planning in 1944–45 was built around tempo. German doctrine had long emphasized methodical preparation for river crossings, suppress artillery, secure bridgeheads, construct heavy bridging under protective fire, expand the crossing gradually. The United States adopted a different rhythm. Cross first. Expand later. In the days following the capture of the Ludendorff Bridge at Remagen on March 7, 1945, American commanders recognized the fragility of relying on a single crossing point. German forces repeatedly attempted to destroy it with artillery and air attacks. The bridge ultimately collapsed on March 17, killing 28 U.S. engineers. But by then, multiple pontoon bridges were already under construction nearby. The tactical shift was clear. Rather than concentrate forces at one crossing, American engineers built several simultaneously. This divided German artillery response and overwhelmed defensive calculations. Night operations became standard. Darkness limited enemy observation. Smoke screens concealed assembly points. Bridging units practiced synchronized deployment, trucks arriving in sequence, pontoons launched methodically, treadways pinned together with practiced precision. Tanks did not wait for daylight. When bridges reached minimum load-bearing capacity, armor rolled across immediately, even before full reinforcement was complete. Speed created shock. German commanders anticipated river crossings measured in days. They encountered crossings measured in hours. And once heavy armor appeared on the eastern bank, defensive coherence began to fracture. The lessons of March 1945 helped shape doctrines that persisted through the Cold War, emphasizing tempo, redundancy, and adaptability over reliance on static natural obstacles. Beyond strategy and technology, the Rhine crossings had profound human significance. Engineers, often overlooked in historical accounts, demonstrated courage and resilience under fire. Their labor enabled the rapid deployment of forces that would liberate towns, secure industrial regions, and hasten the end of the conflict in Western Europe. Soldiers who crossed the Rhine witnessed the fusion of industrial might and tactical audacity, a demonstration that modern war relied as much on preparation and mobility as on combat itself. Finally, the crossings exemplified a shift in the nature of warfare itself. Where rivers had once dictated operational timelines, the U.S. Army's combination of doctrine, engineering, and logistics rendered natural obstacles negotiable. In hours, what was once expected to take days was accomplished. Industrialized engineering became a force multiplier, and speed emerged as a decisive weapon. The Rhine no longer imposed a barrier, it became a conduit for momentum, shaping the final weeks of the war in Europe. With the Rhine secured, Allied forces pressed eastward into the heart of Germany, closing in on the Ruhr and beyond. The collapse of the last major natural obstacle in the west symbolized the broader unraveling of German resistance and set the stage for the final phase of the European conflict. The success of these operations was not merely a measure of territory gained. It was a proof of concept, that modern armies, integrating industry, engineering, and human resolve, could overcome centuries of strategic assumptions, and that the pace of warfare was now determined by those who moved fastest. Remagen shattered the expectation that the Rhine would impose prolonged delay. Yet even as forces poured through that breach, a far larger and more deliberate crossing was about to begin farther north and south, one designed not as an opportunity seized, but as a calculated demonstration of overwhelming force. And on the night of March 22 to 23, the river would be crossed in strength along a broad front. March 23 to 24, 1945, Rhine River. While Remagen had provided an unexpected foothold, Allied commanders sought to eliminate any remaining doubts. The Rhine would be crossed not in desperation, but by design. Operation Plunder, planned by Field Marshal Bernard Montgomery, combined massive engineering, artillery, and infantry coordination north of Wesel. Simultaneously, General Omar Bradley's 12th Army Group orchestrated crossings at points further south, including the sectors near Oppenheim and Mainz. Under cover of darkness, assault boats ferried infantry across narrow channels. Engineers followed immediately, guiding pontoons into position while German artillery tried to target them. Smoke screens, laid by Allied engineers and artillery, obscured movement along the banks. The M2 and M3 treadway bridges were assembled with precision. Sections of steel trackways were connected atop pontoons. Chains were tightened, anchors secured, and floating supports lashed to the riverbed. Each completed span became a lifeline, carrying men, vehicles, and artillery across what had once seemed an impassable barrier. Patton's Third Army, operating near Oppenheim, exemplified the aggressive tempo doctrine. By 2 a.m. on March 23, infantry had secured forward positions. Engineers immediately began laying treadway bridges across strong currents. Within 4 hours, Sherman tanks began moving over the first completed spans, proving that mobility need not wait for full daylight or total stabilization. March 7, 1945, 3:15 p.m., Remagen. The Ludendorff Bridge still stood. American forward elements of the U.S. 9th Armored Division had been advancing cautiously toward the Rhine. Intelligence suggested all major bridges had been destroyed. Demolition was standard German procedure. But as Lieutenant Karl Timmermann's troops approached the heights above Remagen, they saw something improbable through the haze: steel trusses spanning the river intact. German engineers had prepared demolition charges. Wires ran along the structure. Explosive chambers had been placed. At 3:15 p.m., charges were detonated. The bridge shook. Smoke filled the trusses. But it did not fall. The explosion had damaged planking and twisted sections of steel, yet the main supports held. Whether due to insufficient explosives, faulty wiring, or rushed preparation, the destruction was incomplete. Within minutes, American infantry began sprinting onto the bridge. Machine gun fire erupted from the eastern bank. Engineers followed closely behind assault troops, cutting demolition wires, throwing remaining charges into the Rhine. Under direct fire, they worked methodically along the span, neutralizing explosives one by one. By nightfall, U.S. forces had established a small but viable bridgehead on the eastern bank. It was the first crossing of the Rhine by Allied forces. German command reacted with urgency. Adolf Hitler reportedly ordered those responsible for the failed demolition court-martialed. Several officers were executed. The bridge was to be destroyed at all costs. Over the following days, the Luftwaffe launched repeated attacks. Arado AR-234 jet bombers targeted the span. Conventional aircraft attempted low-level bombing runs. Artillery batteries shelled the structure continuously. Even V-2 rockets were launched toward the area, though none struck the bridge directly. In the end, the Rhine was crossed not by sheer force alone but through a combination of human courage, technological innovation, and doctrinal audacity. Rivers that had once slowed armies now bore them forward. Bridges became weapons. Time was compressed. Momentum dictated outcomes. And in those dark hours along the Rhine, history witnessed the emergence of warfare in which speed, preparation, and industrial power could redefine the very meaning of natural obstacles. The lesson endures. In modern war, the greatest barriers are not always physical, but those imposed by expectation, and innovation has the power to overturn them. At a higher level, German engineers documented the failure in post-action reports. Many noted that even with successful demolition of fixed bridges, the industrial scale of American engineering ensured that additional crossings would appear rapidly. One report emphasized that no single river, however formidable, can withstand an opponent who treats bridging as a logistical extension of combat operations. These assessments influenced late-war strategic thinking and, after the conflict, informed NATO doctrines regarding rapid river crossing and mobility in Europe. The collapse of Rhine defenses set the stage for further Allied advances. With multiple bridgeheads secured, American armored units pushed east into central Germany, facing diminishing resistance. Cities along the river, Mainz, Cologne, and Düsseldorf, fell with little delay. The pace of advance, combined with sustained supply and mobility, rendered previously entrenched defensive lines irrelevant. German field command, constrained by fuel shortages, manpower deficits, and disrupted communications, could only react rather than shape events. The Rhine crossings exemplified a broader shift in warfare. Industrial capacity, combined with speed, could neutralize natural defensive obstacles. Where rivers had once dictated operational rhythm, engineering mastery and tactical tempo now imposed the pace of battle. American success along the Rhine demonstrated that mobility and preparation could outweigh static defenses, fundamentally altering expectations on the battlefield. The Rhine crossings in March 1945 were more than a tactical triumph. They represented a transformation in the understanding of mobility, engineering, and operational warfare. Military analysts after the war frequently highlighted the events as a case study in the integration of industrial capability with frontline operations. Across the Rhine, German forces were unable to consolidate. Defensive positions, calculated to repel crossings over days, were overwhelmed by simultaneous assaults along multiple points. Forward artillery observers struggled to adjust fire, smoke, darkness, and rapid construction rendered targeting ineffective. Artillery barrages occasionally destroyed pontoon sections, but redundancy ensured continuity. Replacement pontoons were brought forward by truck, sometimes under direct observation from the eastern bank. Engineers waded into the cold, fast-moving water, resetting anchors, reconnecting trackways, and guiding vehicles onto the floating roadways. By dawn on March 24, the Rhine had been crossed along a broad front. Patton's Third Army had several infantry and armored units east of the river, linked by multiple pontoon bridges. Bradley's 12th Army Group had established bridgeheads near Mainz and Cologne, supported by heavy artillery and supply convoys. Montgomery's forces were ready to push southward from Wesel, supported by engineer-built crossings capable of supporting full divisions. The combined effect was decisive. Where German planners had assumed a pause of days, American and British forces crossed in hours. Armored columns appeared unexpectedly, artillery was positioned on the eastern bank almost immediately, and supply lines kept pace with combat units. Rivers, once considered natural fortresses, had become mere obstacles to overcome. Their traditional defensive value evaporated under the weight of industrialized engineering, doctrinal tempo, and coordinated assault. The psychological impact on German units was profound. Soldiers who expected to use the Rhine as a barrier found themselves facing tanks and infantry in positions they had calculated would remain safe for days. Commanders were forced to retreat, reorganize, and abandon prepared positions under extreme pressure. Their task was not glamorous. They built roads, repaired ports, cleared mines, and, when required, they built bridges under fire. The key difference lay in preparation. Unlike many European armies, the United States approached bridging as an industrial system. Standardized components were mass-produced in American factories and shipped in modular sections. Every piece was designed to be transported by truck, assembled rapidly, and replaced easily. One of the most important systems in Allied service was the Bailey Bridge, a British invention from 1941. The United States manufactured it in enormous quantities. It consisted of prefabricated steel panels that could be pinned together in multiple configurations, allowing engineers to construct bridges capable of supporting heavy vehicles, including tanks. The genius of the Bailey design was its modularity. No heavy cranes were required. No complex tools. Sections could be carried by squads of soldiers and assembled piece by piece. If damaged, individual panels could be replaced without dismantling the entire structure. But for wide rivers like the Rhine, even more flexible systems were necessary. The U.S. Army relied heavily on pontoon and treadway bridges, floating structures supported by inflatable or metal pontoons. The M2 and later M3 treadway bridge systems allowed engineers to lay a roadway across water in sections, locking steel trackways onto floating supports. These systems could be assembled at remarkable speed. Under ideal conditions, a fully functional bridge spanning hundreds of meters could be completed in hours rather than days. Speed was not an accident. It was doctrine. American operational planning emphasized momentum. General George S. Patton's Third Army had demonstrated this repeatedly after the Normandy breakout in August 1944. Rapid advances depended on uninterrupted supply and mobility. Any delay risked giving the enemy time to reorganize.